Hey, what's up, GRE lovers? Today, what we're going to do is we're going to look into a quant section and probably solve some problems. However, the main concern today is about a new technique known as the power of visualization. So the point of doing these questions is to basically give you a little bit of taste at why the power of visualization and the ability to imagine a scenario and kind of like draw it out in front of you is really important. So I think the point is going to be pretty much clear after we solve these questions. So let's go. It says in a company having 50 employees, okay, so there are total 50 employees, okay, so far so good. 36 of the employees can earn a salary that is $40,000 per annum. So out of those 50, 36 of the employees have a salary of 40K and or above, and the rest, what's going to be 14? Yeah, 14 of them have a salary of 40K or lower down. So the question is interested in the median of the annual salaries of all the employees. So the best way to solve this type of question is again to visualize a scenario. So we're gonna start with, okay, so probably this is the first employee, this is the second employee, dot 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 dot, and probably here is the last one, with 50, right? Yeah, 50. And then probably somewhere here in the center, what's going to be the median? 25th and the 26th, right? The mean of the 25th and the 26th, and dot 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 all the way to 50. So just to make it a bit more real, let's say right over here, this 50 dude is the CEO of the company having the highest salary, whereas this one is probably the guard, okay, the guard who's basically checking in, at the standing at the entry gate or whatever, and probably this number two is probably some receptionist or probably sitting at a desk or some complaint desk whatsoever. So now that we are done with this initial picture, I think we are in a pretty good situation to start tackling this problem. So I know that the 40th employee is going to have a salary of 40K and less. So where's the shift here? Let's try to draw the shift. So I'm going to probably remove some dots over here. Okay. So if I'm like, okay, this is the 14th employee and this is the 15th employee, I do know that 15 and above, all the employees have a salary of 40K and plus. And the rest 14 and lower have a 40K or lower. So if my median salary is over here right in the center, which is going to be the mean of 25th and the 26th employee while standing in the line based on how much are they earning, this is going to be definitely either equal or greater than 40K, right? So if my quantity A is 40K or more, then it is definitely bigger than quantity B, and hence the answer must be A. Okay, moving on. Okay, slope of the line joining points M and N. So there are 2 points and there is a slope is positive. Okay, so there's a positive slope such that the points M with coordinates PQ lies in the first quadrant. Okay, and a point N with the quadrants A and B lies in the fourth quadrant. Okay, so there's a lot of information here. Let's try to break it down. And since I know that this is the first quadrant, this is the second quadrant, this is going to be the third quadrant, and this is going to be the fourth quadrant, right? So let's try to break it apart. So the slope of the line of points M and N is positive. So what do I mean by that? So in order to understand what slope really is, let's try to understand with its basic form. It is basically the ratio of the rise over the run. The rise over the run. So when can a ratio be a positive? Well, one case is that both values are positive or both values can be negative. And whenever this type of situation occurs, the line is always going uphill. Like if you move from left to right, it is like an uphill line. It is increasing, right? So another question is like, okay, what about the negative slope? Where in that case, the ratio has the rise over the run has a different sign, and therefore the ratio overall sign is basically negative. So let's say the rise has a positive sign, then the run is going to have a negative, or if the rise has a negative sign, the run is going to be positive. And this line is always going to be a downward hill line. Whenever you're moving from left to right, you're moving downward, down the hill. Okay. So how was I able to come up with this uphill or downhill? I think I really need to just go quickly through the concept here, just because it's going to be practically applied to the question. So let me use a different marker here. Okay, so if I'm saying that, okay, let's try to come up with the first case. Okay, the first case is, okay, the rise over the run both are positive. So the rise, which is basically in positive y direction, it is positive. And since the run is also in the positive x direction, however, if you just meet these two up, you're going to get an uphill direction. Similarly, in my second case, both are negative. Okay, so the rise is basically the opposite, more of like a drop towards the negative y, and the run is also towards the negative x-axis. So if I meet these two bad boys, I see again an uphill direction right over here. However, when I combine the third concept, in which the rise is positive, okay, so the rise is positive, however, the run is negative in the negative x direction. If I meet these two now, I'm gonna get a line which is downhill. And similarly the case with the fourth one. Okay, so you have a negative, a rise, basically a drop, and then you have a positive run, and what you do is you meet these two up, you again get a downward line. So now the question has stated that since I have a positive slope, I have an upward line. Therefore, this information is really important, because if I have an uphill line, that means that it cannot be a simple line, horizontal line, parallel to the x-axis, because this line has a slope of 0. It can also not be a complete vertical line which has a slope of infinity, because you know the axis in the bottom just cancel out and gives us a 0. Anything derived by 0 gives us the infinity. And it also cannot be a negative slope line in which the slope is negative. So now that we are basically pretty much done with our initial concept, I think we're pretty ready to jump to the question and start solving it. Okay, so the point M and N have a positive slope, and the point M lies in the first quadrant. So M is over here, chilling somewhere here in quadrant, and point N is in the fourth quadrant. So N is chilling over here in the fourth quadrant. And then it says the coordinates of, I believe, yeah, the coordinates of N is A, B, and M is P and Q. So it's saying the sum of the coordinates of A and the sum of coordinates of M, which is P and Q. So let's try to come up with a simple example. Let's say if this is 1, 2, 3, if this is 1, 2, 3, let's say this is point M, and P is M, and Q is, P is 3 and Q is 3. If I do the sum, I'm gonna get a 6, right? And let's choose a number, since I'm interested in a positive slope. Let's say this is N, okay, 2 from here and 2 from here. So A is going to be positive, however, B is going to be negative 2, and their sum is going to be 0. And you can see the line, it is uphill. I haven't broke any rules, even though it's an ugly line, but enough to make sense. Now the question is, in this scenario, quantity B is definitely bigger because it's 6 and this is 0, right? Now the question is, can I make this value over here bigger to the point that it can reach 6 or more? So what I have to do is increase the value of this x coordinate and probably decrease the value of these coordinate so that I can finally increase the final value, which is the quantity A. So I think I really need to rub some room and create some room here. Okay, let's just draw it on the side just so that we don't forget. Okay. So I'm trying to increase this bad boy right here. I'm gonna do is increase this value and drop this value, and yeah, okay, while keeping the positive slope. So M is already here, okay? M is already here. Now the question is, how much can I make this bigger? Well, honestly, I can make this bigger all the way here, which is just before 3, because after that it's going to be a vertical line, right? A vertical line, and I would be breaking the initial constraint, the initial rule, so I can't work with that, right? So what I can do is just before the 3, okay, just before the 3, let's call it A is just a little small value, just little than the 3, okay? That's the maximum that I can make. And I need to make this as small as possible. I can say, okay, if I need to keep this n in the 4th quadrant, I cannot make it over here because it's going to be origin. But I can say, okay, let's make it a little bit, just a little bit bigger than 0. So I can say, okay, just a little bit bigger than 0. So now if I take the sum, it is going to be eventually something a bit less than 3, this value. However, this is nowhere near 6. And if I want to increase this value, I have to move to the other side, let's say somewhere here. But the problem is then the slope is going to become negative and it's going to be downhill, which is not allowed to do. So the max that I can do over here is this line right here, which is slightly, not perfectly straight, but slightly, going uphill. But even then, the value is 3 right over here. So no matter what I do, quantity B is always going to be greater, and therefore the answer must be B. Okay, guys, this is the power of, kind of like visualization and trying to, play with the diagrams and trying to think how, these coordinates are going to change. Anyway, let's move to next question. Okay, this question says, in a rectangle coordinate system, calculate the area enclosed by the following system of linear inequalities. Okay, so we have linear inequalities. So the first one is x plus y, which is less than 6. Okay, and the second is x is greater than y, and the third is y is greater than 3. So what I can do over here is probably use this general formula of the line, which is y is equal to mx plus c, where c is the y-intercept, m is the slope, and x and y are variables. So can I create this equation right here in this general form? Well, I can move the x to the other side and say negative x plus the 6. Right? Negative x plus the 6. I think I need to remove this line. Yeah. Okay. So what does this tell me? So I do know that my the y-intercept is 6, and my slope, the rise over the run, is basically a -1. Basically, this means that the rise and the run have opposite sides. It can be any ratio to the form of, let's say, a -1 over a +1, or it can be a -2 over a +2, which eventually gives me -1, something to this effect, right? And all I have to do now is probably sketch these lines and try to come up with how they are interlinked with one another and what area do I need to calculate here. So I do know, first of all, let's try to, label this diagram. So since the biggest number is 6, so I think I probably, how about 2, right? multiple of 2, 2, 4, 6, 2, 4, 6, 2, 4, and a 6, right? And a 2 and a 4 and a 6. Okay, and I think we're ready. So I do know that the y-intercept is 6 right over here. So let's me point it right over here. And all I have to do is, since there's a negative slope, I can say, okay, I can drop down the negative rise and then the positive 2 run. It's going to be this point over here. I can even further go down negative 2 and a negative and a positive rise over here. And I can go further down negative 2 and a positive 2 drop over here. So I can almost see a straight line over here. Let me draw a line. That's gonna, make things a bit easier. Okay, yeah, cool. So even though it's not perfect, but you guys get the idea, right? So this is the overall line. However, y is less than this line. So I can say, okay, so y is gonna be smaller or at the lower side, okay, the lower side. Then I'm looking for an equation which says x is greater than 1. So where is 1? 1 is over here, somewhere here, right? So let me draw a line just to make things a bit, trying the best I can. Okay, probably over here. Okay, going down, down, down. Oh, no, not like that. Yeah, this sounds fancy. So since x is greater than 1, I have to go with the greater side, okay, to the right side. And the last equation that I'm considered with is y is greater than 3. So where is 3 over here? Somewhere over here, right? Somewhere in the middle, 2 and a 4. So let me draw another line. Oops, sorry. Okay, another line, probably somewhere here if I'm not that inaccurate. Yeah, I think that's cool. Oh, no. Ooh, yeah. Oh, no, I messed it up. Let's do it one more time. Okay, careful. Okay, careful. Boom. Yeah, now we're talking. Okay, so since y is greater than 3, so I have to move uphill, okay? Move in up direction. Now that I have basically plotted all of my lines, now I'm seeing a general intersection of these lines, and I'm seeing a right angle triangle which has a 90 at the bottom. So all I have to do is find the sides, right? The base is going to be, it starts with the 1 and then it ends on the 3. So base is going to be 2. And what's going to be the height? The height is going to be, it starts with the 3 and ends at somewhere at the 5. So the height is also 2. So all I'm looking at here is a triangle which has a 90 over here, 2 over here, 2 over here. And all I have to do is find the area, which is going to be half 2 times 2, and 2's are just going to cancel. I'm going to be left with 2 as an area. So area must be 2. Okay, guys, this is it for now. I hope this was helpful and you guys got the power, or you got the point, and you have actually understood that how it is a lot easier to actually visualize and draw diagrams which can help you get to the right answer. Okay, guys, if there is anything else, you can probably comment or probably reach me at abd.gre.toefl@gmail.com. Okay, guys, this is it for now. This is ABD signing out, and I'll talk to you guys later.